Welcome back to a new exciting chapter of object-oriented programming. It's in short, we call it OOP, OOP. Some people pronounce it OOPS, which is an expression which is wrong. You do not pronounce an abbreviation. You just say OOP, and this is object-oriented programming. So what exactly it is? Object-oriented programming, it's a way, it's a method, it's a process actually of writing your computer program by organizing your code around an object that has both data and the operations, the actions within it, specific to it, making it easier to design, understand, and maintain the software. We're going to see some example. One object is a unit which has its own data and its own operations, which is later instantiated. We create instances, like we create variables of several types. And the example that I have here for you is think about a car. In object-oriented programming, a car is like an object with specific characteristics and actions. So car has the color, the brand, the model, the mileage, the number of seats, etc. These are the features. These would be its data. And the methods would be like accelerating and braking and starting the car, turning on and off. So these would be the methods acting using the data of that certain object. The object-oriented programming lets you create a blueprint of a car called class in C++ or Java, JavaScript, etc. Other languages, we call it class, but not in here. We are going to use structure, the struct, struct, that we did previously, very compact data structure. And this actually blueprint defines how every car should behave and what it should have, what features and what methods an object has. So when you want to make different cars, you follow the same blueprint to create them. Exactly using the same way in the software, object-oriented programming makes it easy for us to design and build the cars, the objects actually, with consistent features and behaviors. So we, for example, we create an object for HTTP. We create an object for the window, a small window that's appearing in our application that we are going to see in the GUI programming as well. And it has width, it has length, it has caption, it has borders, everything is a feature. But when you resize it, it's a function. It's specific to that window. When you resize it, when you hide it, when you show it, when you maximize it, these are the features and these are the methods or operations that we perform on the data that is contained within the object. So this was the example so far. There are some advantages. I'm not proposing C to be used all the time for object-oriented programming. Why are we using C for object-oriented programming? The quick answer is it's your choice. I'm not proposing to use it. If you are willing to learn further languages and like C++, Java in the future, or any web programming languages like PHP, Perl, etc., you would be able to, or Python, of course, which is most popular at the moment, you would be able to create different kind of classes and objects. But in here, there are some advantages of using C. Still, we do, and it is the very first advantage is you have a huge community of C programmers, and it's knowledge base and resources, and they have tailored libraries which have been enhanced and rewritten and revamped through the time, through years and years and decades. So they are really consistent and really powerful. So you have a big community. You can utilize their libraries and create your objects using those libraries. And it's accessibility. By implementing object-oriented programming concepts in C, the code becomes more accessible to a broader range of programmers. Because there are many C programmers, many communities, and even it's still taught in universities against this structured programming courses. So more of the people would have access to your code. They would understand your code easily. And then the biggest advantage that I see is it's a true cross-platform. C is cross-platform. You write a code in C, you go compile it on any platform. Either it's a device or a computer, a home computer that you use, or a mobile phone or whatever. You can compile it on a variety of operating systems. Now, you have disadvantages as well, of course. Before that, the efficient resource utilization. Of course, because you are at the low level, really near to the processor memory, you create applications that do not have memory manager or any additional code. The program that you write are really lightweight and their structure are really so lightweight and optimal for memory and resource utilization. In performance critical scenarios, of course, you have a limited memory and limited processing power on a device, then of course you would be preferring C, not any other language for that. And you have a balanced and low-level control. This approach actually retains, if you use C for object-oriented programming, control and inherit the C, which can be challenging to achieve in languages like C++ and Java. And this balance is particularly useful for hardware-centric applications. Like you write a sensor, the temperature sensor, for example, or the fuel sensor, for example, in the car. And then at the end, you have compact footprint. This compact footprint actually means you have smaller executables, and which do not, in the beginning, they do not consume a lot of memory. Then you have complete control of memory utilization as well. You utilize and allocate and deallocate memory as you like. And its memory consumption compared to the overhead associated with C++ and Java runtime environments. Like Java has a runtime environment, which is an overhead. C++, when you compile the program, there is always an overhead. It's not just like a small structure that is going to be saved in the memory. Of course, there are a lot of things that are added to your class when the compiler generates the machine code. These were a few things that I think you should be learning C, object-oriented programming using C. But again, it's not something really so much ideal. It is part of the course. You will learn it. I'll teach you how to do that. If you want to continue or pursue your career in device development, device drivers development, etc., then you would be needing it. And it would be really a big advantage for you. But there are still disadvantages. Like you write a software for desktop applications for Windows, Linux, or Mac, or something like that. And you have a lot of memory. You have a lot of CPU power. So the difference between these two languages, the executables, their execution, etc., it doesn't really matter so much. Even if the application is a little slower, the end product should have all the features. You won't be needing to write a lot of code for doing that. So the limitation of abstraction. In C lacks some advanced abstraction presence in C++, leading to more complex code, reduced readability. So when you write a complex code in C, it's not much more readable as compared to the C++ or Java. Then you have memory management, manual memory management, which actually is an advantage as well as it's a disadvantage. Like the string class in C++, or the vector class in C++, they do allocate the maps. For example, in C++, they allocate memory automatically. And they resize themselves with their constructors and destructors. They allocate it and they deallocate at the end when the program is done. You might forget to deallocate memory in your C programs. You do not have kind of constructors for everything. For all the objects, you can create a constructor for program and destructor for program. Fine. You cannot do for each and every object that you create, and you might forget to deallocate memory. And there is a lack of inheritance. We can create inheritance in C++, C as well, but inheritance in C++ and Java, like modern languages, it's really easy to do. And there's a built-in support in C++, and C does not have that. So we'll have to do it manually. And absence of functions and operators overloading. For example, you say string variable, that variable is x. So you say x is equal to x plus, and then you give a string, literal. And that is appended to the string variable. That is operator overloaded already. So plus actually means it's a mathematical operation, but you are performing on string. So that has been overloaded. You can create those operators overloaded and the functions overloading, of course, as well. You can create overloaded functions, but that's not really easy to do in C, and some of the parts are not even possible in C. And unavailability of template-driven programming, of course, C does not allow us templates. C++ does. This is C++ capabilities, Java capabilities, other modern languages, mostly C++. You use a template to create different classes and objects against different data types and stuff, but that's not possible in C. These disadvantages are given to you not to disappoint you, but to let you know that if you have to do a modern programming for desktop, etc., I would be suggesting, if your application is more specific to inheritance and interrelated objects, you should be using C++, going for C++, not C. But again, if you are doing compact applications, and there's not much uses of inheritance, etc., and encapsulation, go for C, and that would be fine. And most importantly, if you're doing device programming, then C would add an advantage. So how does this single unit actually look like? Data members, it has data members. One object has data members and its operations, the functions it has. So these functions are supposed to operate on this data that one object has. So a single object is a single unit. It has its own data. It has its own operations. It is specific to a purpose. For meeting one purpose, for example, I can give you one more example. There are many examples, but one example would be good. You create an object that manipulates images, for example, pictures. You load the picture within the object, and then you have multiple functions, and these functions actually give the width back of the image, height, the color template, as well as you are able to resize the image, convert the image from PNG to PNG or JPEG or GIF, and you can resize the image, you can draw a watermark on it, etc. So that object would be specific to image manipulation. We'll call it an image manipulation object. That would have all the functionality built in and no function would be outside of it. That would be one single unit. I hope it does make sense. If you have any problem in understanding the concept, let me know. We are going to get into examples now. Thank you.